Welcome to Ask and Learn.
In this problem, a cylinder equipped with a set of stops for the piston is initially filled with saturated liquid vapor mixture of water at a specified pressure. Heat is transferred to the water until the volume increases by 20%. The initial and final temperatures, the mass of the liquid when the piston starts moving, and the work done during this process are to be determined. And firstly, we will show this process on a PV diagram. So initially, we have the volume constant with an increase in pressure until the piston is moved off the set of stops. So process 1-2 is at a constant volume and increasing pressure. Process 2-3 is when the piston is lifted off the stops and the volume increases by 20% at a constant pressure. Now we assume this process is quasi-equilibrium. So the first thing we will do for part A, initially the system is a saturated mixture at 160 kilopascals of pressure. And so the initial temperature of the system, T1, we get from our tables. So that's a temperature at 160 kilopascals, and this is 113.3 degrees Celsius. The total initial volume of the system, V1, is equal to the mass of water in one state plus the mass in the liquid state. So the mass in the vapor state plus the mass in the liquid state multiplied by the corresponding specific volumes. So we get again these from the table. So this is 1 times 0.001054 plus 2 times 1.0915. And so we get the total initial volume to be 2.184 cubic meters. Now the total and specific volumes at the final state, remember the final state is V3, or state 3, the total volume is 20% greater than the initial volume. So that's 1.2 V1. So it's 1.2 times this value above. And that's 2.621 cubic meters. The specific volume at the state V3 is obviously the total volume divided by the mass of the mixture. And this is 2.621 cubic meters divided by 3 kg. And so we get the specific volume to be 0.8736 cubic meters per kg. So now we can find the temperature at this state. So the pressure at this state is 500 kilopascals. And the specific volume, V3, is 0.8736 cubic meters per kg. So this corresponds to a temperature in our final state, T3, of 675 degrees Celsius. So we have the temperature in our final state. And that's our answer for part A. Now for part B, when the piston first starts moving, we have P2 is equal to 500 kilopascals. And V2, so P2 is equal to 500 kilopascals. V2 is equal to V1 is equal to 2.184 cubic meters. Piston hasn't moved off from its stops just yet. Now the specific volume at this state, little v2, is the total volume V2 over m. So that's 2.184 cubic meters over 3. And this is equal to 0.7280 cubic meters per kg. Now, this is greater than Vg of 0.3748 cubic meters per kg at 500 kilopascals. So that means that no liquid is left in the cylinder when the piston starts moving. Now, for part C, no work is done during process 1-2 since we have a constant volume, V1 is equal to V2. The pressure remains constant during process 2-3, and hence we can calculate the work done for this changing volume. The boundary work, W, is the integral from process 2-3 of P dV. So this is the constant pressure P2 into the volume V3 minus the volume V2. So this is 500 kilopascals into 2.621, which is V3 minus 2.184 cubic meters. That's V2. And hence we get the boundary work done for this process to be 218 kilojoules.